Ladies and gentlemen, you are welcome to my YouTube channel. Today we are going to look at the MCQ in chemistry for JAMB and first UTME student. Let me start with the question one here. The question one says the minimum amount of energy required for effective collisions between reacting particles is known as E. Activation energy, B. Bond energy, C. Kinetic energy, D. Potential energy. Generally, ladies and gentlemen, for a chemical reaction to occur, there must be a reactant particles. Let's say A plus B react together to produce C plus D. But before this reaction takes place, they must overcome there must be a minimum amount of energy that these reactant particles must overcome before the reaction takes place. And that minimum amount of energy is called activation energy. So let's look at classically how this activation energy is represented. So look at it. This is a reactant particles. We have a reactant particles here. And this is the activation energy. This is the activation energy, and this is the product. So before the reaction takes place, the reactant particles here must collide, and the collision must be perfectly elastic. And as a result of that, a sufficient amount of energy will be produced in order to overcome the minimum amount of energy, which is activation energy. Therefore, the answer to this question is activation energy. Therefore, for the reaction to occur, the minimum amount of energy must be overcome by the effective collisions of the reacting particles. And if this minimum amount of energy is not overcome, it means that the reaction will not take place. So the answer is activation energy. Then the bond between water molecule and hydrogen ion to form hydroxonium ion is A. Dative bond, B. Covalent bond, C. Electrovalent bond, and D. Ionic bond. So actually, when we said coordinate, covalent bond is the same thing as dative bond. So dative bond is the same thing as a covalent bond, and when we said dative bond is a type of bond that involves sharing of electrons. But generally, the sharing of electrons is unequal. It's just one species of the atom that donates or that share the electrons, while the other atoms do not share any electrons. So therefore, now look at this. The atoms 1 here have 2 electrons here in red, while atom 2 here, the atom 2 here, if you can clearly see, there is no any electrons occupy this space. So therefore, the 2 electrons here from element or from atom A will be shared with atom B. So if you look at it here, you can see that it's only atom 1 that share electrons, while atom 2 do not share any electrons. So the types of bonding in which there is an unequal sharing of electrons between 2 or more atoms is considered or is defined as a dative bond. Like for example, now in the case of water molecules and hydrogen ion, of course, when we have, this is the normal electrovalent bonding of, this is the normal electronic configuration of hydrogen. So in the normal electronic configuration of hydrogen, you can see clearly that in the first shell, we have 2 electrons. And in the second shell, we have, of course, for oxygen, we have 2 electrons here. So we have 1, 2, 3, 4, 5, 6. So oxygen has 8 electrons. So therefore, here there will be 1 hydrogen will now share its electron here, then another hydrogen will share its electron here. And that's what, because this one is oxygen, this one is oxygen. So we have 1 oxygen and 2 hydrogen making the water molecule. And then of course for the hydrogen ion, when we said hydrogen ion, it means that it doesn't have any electron. So hydrogen ion doesn't have any electron. It is 0. It doesn't have any electron because it already loses its electrons. That is why it is hydrogen ion. So therefore, this hydrogen ion will now share 2 electrons with oxygen, and the 2 electrons only coming from the oxygen, not from the hydrogen. So that describe, or that actually shows that the answer to this question is dative bonding, because there is an unequal sharing of electrons between hydrogen ion and oxygen from water molecule. So then we have an element X which forms the following oxides. So these are the 3 oxides that was actually generated: X2O, XO, and XO2. So this phenomenon illustrates the law of A, law of conservation of mass; B, definite proportion; C, mass action; D, law of multiple proportion. So actually, according to the law of multiple proportion, it said that when 2 elements combine to form different compounds, the same of one element, sorry, the mass of one element combined with the same mass of the other element, but in a simple whole number ratio. So that is what happened. Like for example, this is oxygen and oxygen. So we have this is 1 atoms of carbon and 1 atoms of oxygen. So 1 atoms of carbon plus 1 atoms of oxygen would give us 2 atoms, will give us 1 atoms of CO. And of course here, 1 atoms of carbon plus 2 atoms of oxygen give us CO2. So you see, this is an element, carbon, which actually form more than 1 compound, but in simple whole number ratio. Like for example, the ratio of carbon to oxygen here is 1:1 in the case of CO, and in the case of CO2, the ratio is the ratio is 1:2. So when you have 2 elements and combined to form different compound, you see the CO here and CO2 are not the same compound, but they are the same element. So they combine in a simple whole number ratio to form different compound. So that describes a law of multiple proportion. So the answer to this question is D. So now, how many atoms of oxygen will contain 1.204 times 10 raised to the power of 24 molecules? Note that Avogadro's constant is 6.02 times 10 raised to the power of 23. A, 1, B, 2, C, 3, D, 4. So remember, actually, when you want to calculate the number of mole, you can use this formula, which says the number of particles, or it can be the number of molecules divided by the Avogadro's number, and the Avogadro's number is 6.02 times 10 raised to the power of 23. So therefore, with this formula, you can do this calculation. And how are you going to do it? You just take this 1.02 times 10 raised to the power of 24 as a number of particles, and then you divide it with 6.02 times 10 raised to the power of 23. Then the number of moles of oxygen will be calculated. So the answer to this question, after I do the calculations, is going to be 2. So if you take 1.204 times 10 raised to the power of 24, it will give us 6.02 times 10 raised to the power of 23. So now let's look at the next question. So question 5, which of the following statement about solid is correct? A, solid particles are less orderly than those of the liquid. Solids have lower densities than liquids. Solid particles have greater kinetic energies than those of liquids. Solid particles cannot be easily compressed. So of course, the order and the arrangement of solid particles is far better, is more order than liquids and then gas. And of course, the density of liquid is higher than the density of all other state of matter. And of course, the kinetic energy of the particles of solid is very low. It's lower than the other classes of matter, because kinetic energy is the energy in motion. And of course, because of the arrangement of solid particles, it is not easy to compress. It's not easy to easily compress it. So the answer is D. So question 6, which of the following apparatus can be used to measure a specific volume of a liquid? A, beaker, B, conical flask, C, measuring cylinder, D, pipette. The answer is pipette. Then the general gas equation, PV over T is equal to K, is a combination of, so this is a general gas equation, PV over T is equal to K. So A is a combination of Boyle's law and Charles' law. B, Boyle's and Graham's law, Charles and Graham's law, D, Dalton's law and Graham's law. So the answer is actually, look at the Boyle's law. Boyle's law is equal to PV. PV is equal to K, while by Lewis' law, phi is equal to KT, where N and V remain constant. And for the ideal gas law, PV is equal to nRT, where R is universal gas constant, and of course the R is constant, which is 8.314. And we have Charles' law, V is equal to KT. So actually, by looking at the Boyle's law and Charles' law, you realize that the general gas equation is a combination of Boyle's law and Charles' law. So the answer is Boyle's law and Charles' law, which is option A. So the spreading of a snow of a flower is in a garden is an example of A, Brownian motion, B, diffusion, C, osmosis, D, Tyndall effect. So the answer is diffusion. So now propane and carbon dioxide diffuses at the same rate because hydrogen have a mass of 1.0, carbon 12.0, and oxygen 16. So we have to look at the propane and carbon dioxide and calculate their atomic masses. So let's look at the option. Is that diffusion? Why is it that they are diffusing? Same A, because they are both gases. B, their molecules contain carbon. C, they have the same relative molecular mass. D, both are denser than air. So the answer is C, because both of them have the same molecular mass. Relative molecular mass. So let's look at this to see if it is correct that they have the same molecular mass. Of course, we know that CO2 is like this. So we have one carbon. So one carbon times 12 plus oxygen, we have 2. We have, of course, 2 oxygen. So plus we have, let's put this in bracket. So we have plus 2 oxygen times 16. And this will give us 1 times 1 times 12 is 12. And we have 2 times 16, 32. So this will give us 44 grams per mole. And then, of course, for the propane is C3. Propane is C3H8. So we have 3 times 12 and plus 8, because hydrogen is 1, so 8 times 1. So this will give us 3 times 12 will give us, of course, 36 plus 8, so it's 44. So because they have the same relative molecular mass, that is why they can diffuse at the same rates. So now the energy which accompanies the addition of an electron to an isolated gaseous atom is A, atomization, B, electron negativity, B, electron affinity, D, ionization energy. So actually from the word electron affinity, it means electrons lovers. So they like electrons. They wanted to add electrons always. So the answer is electron affinity, the ability of an element to attach electrons from an isolated gaseous atom is what's described as electron affinity. Then an aqueous solution of ammonium sulfate is A, acidic, B, alkaline, C, amphoteric, C, neutral. The answer is acidic. It's an acidic oxide. So then when a pH of 4 solutions, M, N, Q, and R are 2, 6, 8, and 11 respectively, which of the following deductions about the solution is correct? A, the pH of N is increased when the solution is diluted. B, the pH of Q is increased when the solution is evaporated. C, M is the most alkaline solution. D, R is the most acidic solution. The answer is A. So consider the following reaction equation. Hydroxonium ion plus OH will give us 2 molecules of water, and the reaction result A is esterification, B hydrolysis, C neutralization, and then D redox. The answer is neutralization. So ladies and gentlemen, please follow and subscribe to my YouTube channel for more videos.